What's our next stop? Our next stop is going to be Creation Watch. So, Creation Watch this week, we are going to be talking about beauty. I need to raise my chair up. So, a little bit of woo goes a long way. It does, Doubting Thomas. That's why I give you just a taste of the woo before we move forward. And if you like woo, how about an argument from beauty? Because to me, that's pretty woo-woo. But we'll talk about that as we move through the topic. This is going to be a clip from, actually on Cindy Lincoln's channel. Cindy Lincoln is one of Kent Hovind's ex-wives. She's still a prominent creationist voice. She's a fairly nice lady. I've seen her engage with Dapper Dino and such. However, she is a young earth creationist and supports young earth creationist ideas that I have to put under the microscope and break down. So let me pull Miss Cindy Lincoln's video up here and have a look. This isn't actually her video. It's from a different I guess set of videos that she's promoting. So here we go. Beauty created for its own sake would be absolutely fatal to my theory. Look at some different things that are considered beautiful. There's our beautiful butterfly.
There are at least 8 million different species of animals and plants. And for more than a century, the go-to explanation for their incredible diversity has been the theory of natural selection. Charles Darwin's hypothesis of gradual, undirected biological change has...
So there's our red herring right there. Undirected change. There is direction. I know it's hard to believe a atheist, agnostic, a skeptic is saying there's direction. No, when you look at what the theory of evolution says, by means of natural selection, the word you need to focus in on there is selection. Selection means that it's not unguided, that it's not random, that it is a selection process, that organisms are selecting to reproduce with other organisms that have the best means of producing viable offspring. There are a multitude of cues that different organisms will use to signal that, and we're going to talk about that. And that's not the only cues that we get from having bright colors, but we will. This is going to be a minute, so hang in there.
Had enormous influence on both science and philosophy.
Red-eyed tree frog.
Yet can a purely materialistic process actually account not only for the stunning variety of living organisms, but also for their extravagant beauty?
I think the place to start with natural selection and beauty is Darwin himself.
So we are going to do some Darwin quote mining here. So I do want to encourage everybody, whenever you hear, and they do like to appeal back to Darwin himself, and there's nothing wrong with that. I mean, if you want to engage with the things that were actually proposed by Darwin, you do need to hear, do not just get a snippet of the quote and then not any kind of follow-up regarding what Darwin actually had to say about the topic. That's one thing I do want everybody to take away from this, because we're about to dive into that, and you know how that goes. Why did it switch which screen it was showing? Oh, duh. There we go. All right.
He wrote once that every time he saw the tail of a peacock, it made him physically ill, sick to his stomach, because he's looking at something that goes well beyond what his theories, either of natural selection or sexual selection, can explain.
To better understand Darwin's concerns about beauty, peacocks, and their threat to his theory, Let's take a closer look at those feathers.
You see the peacock's tail and you go, wow. It's a visual crescendo of symmetry, harmony, coordination.
Yeah, so the actual quote is, "The sight of feathers in a peacock's tail, whenever I gaze at it, makes me sick," Darwin wrote. Yeah. And I pulled up the quote on that because I wanted to make sure that we were giving this full exposure. Darwin had the courage to face the implications of what he had done, but poor Wallace couldn't bear it. The very comprehensive view allowed him to see things he perhaps didn't. He was so sure of his central idea, the transmutation of species and natural selection, that he had to find a way to make it work. Yeah, this is
among all the elements of the design. And the deeper you look, the more interesting it becomes.
An adult male peacock has, on average, about 200 individual tail feathers.
And please understand as well that when you look at a peacock, and you look at the tails, and you look at the colors, and you just take in all that beauty, which we will again talk about, because this comes back to the pareidolia kind of thing too, because we also have a interesting color spectrum that leads to this great contrast that allows us to pick out foraging items. But we are also makes our eyes so that we pick out contrasting colors, because what you see when you look at a peacock or other colorful bird, for that matter, any colorful bird, or a butterfly, but the butterfly, completely different light spectrum, you are not seeing what the peacock sees, what the female peacock sees when she looks at this. There's a lot more going on here than what we can see with our perception of the color spectrum. Birds have a much wider range of color that they can see on both ends. For most species, they can see better down into the infrared and up into the ultraviolet as well. Now, insects can see up into the ultraviolet well beyond anything any vertebrate sees in that spectrum of light. Fortunately, their brains usually aren't advanced enough to process too much of it, but insects cannot see in infrared. So, yeah, that's a interesting fact for you. So when a butterfly sees another butterfly, they are not seeing the same color or necessarily the same patterns that you are seeing. When a peacock spreads its tail feathers out for the peahen is not seeing the same colors and patterns that you are seeing, due to them having completely separate spectrums of light that they can absorb and visualize. So you think that we are seeing beauty here, but you have no idea what the peahen is seeing. You are seeing beauty because your eyes are evolved to pick out color patterns, and you are drawn to brightly contrasting colors, which is because the fruits and such that we foraged on in the past would grow in bright colors. So that would encourage us to eat them. We'd eat them and spread the seeds, not just humans, but our primate ancestors, as well as the ancestors of birds and bugs, all spectrums of life that have any kind of visual acuity to see colors can pick out these contrasting fruits, and that has allowed us to see the bright colors. So now we're seeing bright contrasting colors, and our natural, as we spoke about in CryptoCorner today, our natural trend towards picking out patterns and pareidolia makes it so that we see colorful patterns that we interpret as beauty.
170 of them feature a decorative eye spot, and 30 are crowned with a wing-shaped plume called a T. When displayed during courtship, the feathers form a magnificent fan, where every eye spot and T are uniformly spaced and geometrically balanced to create a showcase of pattern, symmetry, precision, and design.
to say it's design, though. It's efficacy. It's a display structure to show the fitness to the peahen. And again, what you're interpreting is beauty is actually a message of fitness to the interested females in the area. Saying, look how fit I am. I have all this extra energy to waste on this monstrous, elaborate tail that actually hinders me. But I'm such a impressive specimen that I can persevere even with this trailing behind me.
This bird is a living, breathing work of art. And when we move in close to the details, we see craftsmanship and planning and subtle engineering that's just utterly obvious.
So, does everybody have their incredulity goggles on? Because these creationists can't understand why or how over generations subtle changes to the structure of a feather can generate a display structure like this. But I think my audience can. I think we are a lot that is going to be able to grasp that.
The shape of every eye spot is defined by rows of multicolored branching strands called barbs.
Mm-hmm.
Moving closer, we see that each barb contains thousands of barbules, microscopic filaments tightly compacted along a rigid shaft.
Barbules, they're little hooks that the concept of hooked structures, I think they're in birds. I think they're made of chitin, I want to say. The barbules, just little chitin hooks. If that's too complex of an idea of something that can evolve, I guess, curved little hooks of chitin.
And the surface of each barbule is segmented into crystal-like bands of molecular jewelry. These barbules are reflective, so they glimmer and change color when struck by light.
Well, some of them are. It depends on how the pigmentation is set up in that. Because like blue is there's no blue pigment in the animal kingdom, at least not in tetrapods, and we have to essentially reflect back absorb the green and red light wave, but reflect back the blue in order to get what appears to be a blue pigment.
From different angles.
The total effect of all this decoration provides an excellent example of what is known as gratuitous beauty. That's beauty that goes way beyond what's needed to attract a mate or to provide some other survival advantage. In other words,
I mean, it's gratuitous. I don't disagree with you. It's what evolution gone wild, I guess. You see it with other fitness displays too. Like the main thing that comes to me is like the giant deer, what they used to call the Irish elk, the cervids that had just massive antlers that just as generations went by, they just kept getting bigger and bigger and bigger to be a sexual display to say that they're healthy, and just it got, I mean, to the ridiculous extreme. But here we are, and they did not survive. Now the peacock, on the other hand, it's managed to carve out a niche for itself. I don't know, gorgeous animal, but having a gratuitous display structure, I don't think is evidence of creation.
you have features that look like they're there for no other reason than to be gorgeous, to be beautiful.
Right, and there's more that I didn't mean to freeze him with the wink going on, but to you too. But you are not even seeing the whole picture of what the peahen sees. She sees all kinds of beauty.
To be breathtaking.
In nature, gratuitous beauty is not limited to peacocks. for the animal and plant kingdoms are filled with striking visual displays that each evokes an obvious question.
It's almost like having bright colors conserve.
Actually possible through natural selection?
It's almost like having bright colors conserve biological purposes and ecological purposes beyond just what humans perceive as beautiful. Like the beetle doesn't care that you think it's beautiful here. It cares that perhaps this coloring is aposematic and it's warning predators who eat me I'm poisonous. Perhaps this color is, I don't know this with this particular beetle what the drivers were for this metallic color, but there are so many different factors that could come into play. And with the flowers, I keep showing flowers blooming. The flowers are brightly colored in contrast to the green leaves to direct the pollinators towards them. It's evolution. They need to be beautiful and brightly colored because that's what the bees are and beetles and bats and birds are looking for.
A blind process devoid of foresight or purpose that theoretically constructed every detail in every organism through a series of biological accidents, random errors in the genetic code.
No, because randomness by definition is going nowhere in particular. So,
but it's not random. Again, we come back to that. This is where we circle back to random. So random and selection cannot be synonymous. Either these genetic traits are being selected for in the population, or they're just randomly passed down. It's one or the other. And what we understand of the way genetics happen is they are selected for. The males of the peacocks with the most luxurious tails have a better mating success than ones with less luxurious tails. So there's always going to be a driving force to have better and more luxurious tails until the size and shape of the tail becomes a hindrance to the creature's survival. That's kind of where the cap goes. Once it becomes, and that's what happened with the giant deer, the Megaloceros, which Ring has provided the spelling for in the side chat there. So that's the giant deer that I was speaking of. They hit a plateau on this antler size, and then it became too much, and they weren't able to even sustain a population.
The method of explanation, the tools of explanation that natural selection gives us are far too crude for what they need to explain.
It's because natural selection isn't just one thing. It isn't just this female organism picked this male organism to reproduce with so that their offsprings would have potentially these traits which aid in their reproduction. No, it's much deeper than that. She picked this male to have this offspring with, but then this environmental factor caused this change, which that male's DNA did not, or which the traits from that male were not as successful as traits with, darker coloration or whatever to help hide from predators better, because new predators moved into the area. Things like that. So many factors. Because it flooded and now it's a wet environment, and the ones that have a bill, the birds that have the beak that is better for catching aquatic prey are more successful. Just little factors like that. But when it comes to beauty, if you're living in a green forest and you're wanting to attract a mate, it's not going to help to have green feathers. You're going to want to have brightly colored feathers. Just for example.
Give me an example of chaos and chance producing beauty, and I'll rethink it. But what I see chaos and chance producing is more chaos.
I don't know why it's chaos and chance. It's selection. Again, as I said before, selection is not random. It's not chaotic, and it's not chance. There is decision being made here among the population, among the organisms. They are choosing, they are selecting who they reproduce with, or when they reproduce if they're asexual, or where they reproduce. So many factors go into selection that are going to weigh the success of the population that is produced by those selections. It's not random. Anything but, actually.
It's in chance.
To better grasp the artistic limitations of natural selection, consider the planning, imagination, and skill required to create one of the most famous paintings in history, Michelangelo's mural on the ceiling of the Sistine Chapel.
Looking at the ceiling, you have a coherent story. There is a unifying thread of biblical themes that brings it all together. There are symmetries in the way that things have been painted and arranged.
Yep, and you can tell that that it wasn't just splashed on there all at once. That this painting was laid down one brushstroke at a time, slowly over years. This image slowly evolved from brushstrokes. Were those brushstrokes random, or did the artist select where they were putting the brushstrokes? So you want to personify natural selection, that's fine. You want to personify the females of a population choosing where to put their brushstrokes for the next portion of the image, and say that that's God. That's natural selection. That's so. Females choosing their mates as God is a weird argument.
The use of the space, the way that figures stand at particular intervals in relation to each other. And you see exquisite brushwork over this enormous surface. Just this overflow of artistic genius. It's the antithesis of randomness. In the Sistine Chapel, randomness would be a bucket of paint accidentally kicked over and splattered on a wall, or a bunch of stains.
Right, and that's the creation model, is just splash, and it's the Sistine Chapel. Not change over time, one little change, one brushstroke of paint at a time over years and years. No, the creation model is splash, you have the Sistine Chapel. The evolution model is one brushstroke, specifically selected colors, selected places, selected locations, selected timing, when that goes down, selection. Yes. Whereas random, it would be, splash, and then the Sistine Chapel's there. Random is creation. I don't know. I wouldn't say it's random. Maybe everything was chosen in it, but the method by which it was put up there was splash, and you have it.
Right? Flaking paint. The ceiling's coming down. We got to get Michelangelo in here to fix this mess. We have randomness and Michelangelo, and they are polar opposites.
Right, I agree with that. And evolution is not randomness. Evolution is selection. It is, again, a reproductive organism choosing its mate, choosing the location it lays its eggs or gives birth, choosing the environment, choosing the time of year that it decides to reproduce, whether or not to abandon its nest when a predator approaches, whether to fight or flight, all these different key factors that come into selection and what selection is. Selection is not just her saying, I'm going to choose this male because he has a big pretty tail. There are other selective factors that come into play as well.
Similar principles hold true in nature. If the random genetic mutations so essential to natural selection have no eye for blending colors or ability to formulate elegant patterns and shapes, then there must be some other agent responsible for the glorious petals of a lily.
Yeah, natural selection. Again, plants produce colorful, attractive flowers not to attract humans to say, oh, that's pretty, I want to put that in my backyard, but it's to attract pollinators to say, hey, this is where the yummy stuff that I make is. If you come get it and carry my pollen to my lover, please. So it's a flag. With flowers, it's a big flag. With other organisms, there's other reasons, of course, like other than mating selection too, for things to be brightly colored. There is, of course, aposematic coloration, which is to say, I'm poisonous, I'm dangerous, don't mess with me. And you have to be bright and stand out from your environment to say, here I am, I'm not hiding from you, because if you eat me, That's your problem. And then there's, of course, mimicry, which Batesian mimicry would be an organism that's not poisonous. But if I look like the poisonous guy, I will not get eaten as well. So then there's Batesian mimicry. So why things are brightly colored and what we would consider beautiful is because the way that we pick out our food gave us or the way that our ancestors picked out our food gave us a color spectrum where we pick out contrasting, brightly colored, especially in shades of reds and pinks, which is ironic because there's a pink flower up here to appeal to us. That's why a lot of the fruit that we cultivated is red, because we weren't the pollinators for the fruit, because the flowers are brightly colored, the fruit are brightly colored because we are seed dispersers. That's why they're attractive to us and attractive to primates, because we disperse their seeds. And red is the best color to contrast green, obviously. So most or the majority are somewhere along those lines of the color spectrum. Of course, there are other colored fruits as well, as we all know, but.
And the ornate decorations on a butterfly's wing.
You don't even get to see all of what's on the butterfly's wing, though. Again, we don't see all the color spectrum, so they're seeing all kinds of cool stuff we don't even get to see.
A designer whose works far exceed the constraints of Charles Darwin's survival of the fittest.
What we see in beautiful systems are...
Beautiful can be survival of the fittest. You're fit if you're bright colored aposematic coloration in your little frog. That is a benefit to you to be that beautiful color, because it's telling things not to eat you.
Are features that go beyond what's necessary for mere survival. So for me, ultimately, beauty points to design, because in a biological...
They don't have to, when you say necessary for survival, where are you making that decision? You do not know what is being selected for and why. We can make inferences about characteristics, and some of them we can make fairly accurate, or what we appears to be accurate based on data. But as for like coloration and things of that nature, there's multiple reasons why that could be. It could be sexual selection, predatory aversion, camouflage.
Logical context, beauty is an extra. It's an add-on. Beauty is there.
Beauty here is not an extra. Beauty here is a warning to predators for this organism, saying, "Do not come near me. I have venomous barbs." Same warnings used by the blue ring octopus in this case, but this is a sea snail.
Over and above what's needed just to make a go of it.
And those, check that out. Eye spots. Eye spots are another feature to distract. See how the actual eye itself is camouflaged into the pattern of the fish, but this eye is the eye spot is standing out. That's to confuse the predator on which way the organism is facing and which way it's swimming. So that is a practical physiological feature.
Did just to make a go of it.
And vertical stripes also break up the outline of your body as you move among any coral, for instance, here, or seagrasses and things of that nature.
Well, you start walking along that path, and it doesn't take very long until you realize you come to grips with the reality that there was a transcendent mind.
And then, of course, a betta fish is same situation as the peacock here. It's a display structure
that put this universe together as we find it. What we have right in front of us in the peacock, in tropical fish.
And you can coax the fish to have bigger tails in captivity because there's no environmental pressures that prevent their tails from going big. Because in the wild, of course, your tail starts to get too big and burdensome. It starts to inhibit your survival chances, makes you an easier target for prey, makes you slower, get lots more drag through the water, trouble collecting food, not being able to fit into these tight spaces, things like that.
In the eye of the eagle.
You want to talk about the eye of the eagle? we're going to get back into the visual cortex of birds, and there's a lot to go over there. They see different colors that we see. They see different spectrums of lights than what we are able to see. Eagles, particularly, are able to pick out motion in a way that we cannot. They can pick out much more subtle movement because their ancestors hunted rodents of all things. Isn't that wild? Because they can see just the heartbeat of an animal through its skin.
In these exquisite designs that show not just engineering, but artistry, whimsy, humor, subtlety.
I want to see the humor. Because it's humorous to humans, because humans find something whimsical doesn't mean that the organism does.
All the features of a supreme intellect.
Hey, Bread of Life, good to see you, Rebecca.
And the final point, the one that really brings it home, is this idea of beauty, of a property that we perceive, that we understand, that we feel, that we respond to, that goes well beyond what living things need just to get by.
Right, and that's because we've been able to separate ourselves quite a bit from the natural world, start creating art. Once you have an idea of making art and using pigmentation to be representation of the world around you and doing different colors and shapes, and your brain really starts to expand, and our species, that's when we really started to take that gift that we had of being able to pick those colorful berries out among the green foliage, or to be able to pick the tiger's face hiding in the forest. We were able to depict those things and put them on the cave wall or on papyrus scrolls and things, and able to start producing what we call art. An artistic mind started to interpret things in nature as artistic as well. So, the fact that we can infer art because the way that our brains are wired does not mean that the pareidolia, it does not mean the face and the wood knots is actually there. It does not mean that the eye spots are for you. It does not mean that all this beauty is there for us as humans to behold, because again, with birds and insects, they're seeing entire spectrums of light, so they're seeing patterns and colors and flowers and each other and in their mates and their predators. Predators are seeing things in their prey that we as humans cannot see because we do not have access to that spectrum of the visual context that they're seeing things in.
That signal carries us beyond the world itself to a cause that's transcendent, to a cause that's divine. The world is designed. It's the only reasonable thing to infer from what we see.
Yeah. All right, so that was Creation Watch, and that was from Cindy Lincoln's YouTube channel. I'm not sure where the original video is from. She doesn't have a citation, I don't think. It says Beauty, Darwin in Design, The Peacock Scream, Beautiful Creator, Not Survival of the Fittest is the title of the video. And it's from, I guess, this John project that she's citing here. John 1010 project. Okay, so that was Creation Watch. And we looked at beauty. Were you convinced by an argument from beauty? I was not. You're loving the creation video? It's on Cindy Lincoln's channel if you wanted to watch the whole thing there, Rebecca. You think God made them to delight me? That'd be sweet of him. But, you know, some of the other things he's done, I don't know if creating beautiful creatures for me is going to make up for those. But that's a discussion for another day.